This is so huge, being introduced by Jake Archibald. That's like that's my most favorite moment in my life, I guess. I tried to make some video of how I feel right now, and that's everything I can come up with. Do we have sound? Yeah. Really enjoying the aquarium club. And yeah. Well, credit where credit's due. That joke was made by Tobias Ballov just 4 days ago, and he took one of my jokes, so I took one of his jokes, and I thought this might be a good idea. Yeah. So yeah, well, that's how I feel. Anybody who had a crush on Princess Leia back then? Sorry that I ruined it for you. But yeah, I'm talking about performance here, and I have been introduced by a performance god, so actually how I really feel, how I think this might turn out, is more something like this.
Are you not entertained? Are you not entertained?
Yeah.
Is this not why you were here?
Basically, I'm having my Tim Berners-Lee moment right now. Which is kind of weird because I did nothing. You know, I met so many people here who did so much great stuff. On Wednesday, who has been here on Wednesday? Yeah, I met Jonathan Snook. I wouldn't say he's a childhood hero of mine, but a mid-20 hero of mine. And yeah, you know, walking around, meeting so many great people, and telling everybody, hey, fan of your work. The only thing that I did that got kind of popular and recognized was this one joke back then, about 1.5 years ago. What's Bower a package manager? Install it with npm. What's npm a package manager? Install it with brew. What's brew? I'm sure you can install it with apt, something like that. And I think the joke was much better back then, and it's better than jokes about how a really good service has no padding modules. But hey, I'm here to talk about HTTP2 and how to unbundle all the things. And when I wrote this proposal, it was called HTTP2 is coming. Actually, HTTP2 is here. And the question is unbundle all the things. This professional drawing of Edward Stark was done by my colleague. The other one was done by me. So in case you wonder what's going on there, that's the main JavaScript file going to be beheaded because we are going to unbundle all the things. But you know, this is, every time you hear about HTTP2, you hear this one advice or this one rule, unbundle all the things, no concatenation, no more bundling, no more packing, what's it called? I don't know, browser API, webpack, all get obsolete, I don't know. And I don't like jumping to conclusions like that. I always want to know why we are doing something like that. I want to know why these things happen. This is like the one time, back in the early 90s, at my place, it was a lovely, lonely village with about 700 people living in there, and they got a pizza joint. This was the first time those people ate pizza at all. And every slice of pizza was served with ketchup and mayonnaise. And so we thought, yep, this is how you eat pizza, with ketchup and mayonnaise, not knowing that this was a sacrilege. So when I got first time outside of my village and had real pizza, I tried to question why did we get ketchup and mayonnaise. Turns out the pizza was so bad you couldn't eat it without it. But you know, that was just kind of this rule. You saw everybody in my village back then eating pizza with ketchup and mayonnaise, so you did it. And I wonder if that's the same case with HTTP2 and not bundling stuff. So I want to question why. I want to know the whys and why we are doing stuff. And to do so, we have to go back to the 90s, to my pizza joint adventure, to Tim Berners-Lee. You've seen him already. And this is Tim Berners-Lee accessing the web page from his office PC. This is the first web server being at CERN, so that was in the basement of his office building. And this was the World Wide Web. The World Wide Web. Kind of small word, but what Tim Berners-Lee did, he invented two things. One thing was the hypertext markup language. The other thing was the hypertext transfer protocol. Anybody remembers them? must be a thing of the 90s. And the hypertext transfer protocol was made to transfer stuff like this. So it was a protocol to transfer text documents from the basement of CERN up to the first floor where Tim Berners-Lee was. And from back then, in terms of protocol, nothing much has changed. We are still working with kind of the same protocol. A few edge cases here and there, but other than that, we're working with them. HTTP builds up on TCP. You've heard that yesterday at Jan's talk. TCP has some sort of three-way connection that's like a secret gang sign with your drug dealer or something. I guess if you add TLS to it, it's like making sure nobody's a cop. And they have this is a round trip. This goes to the internet and back again. So before data can be sent, what browsers and servers do is like communicating and making sure we are knowing each other. And the first version of the protocol could just handle one request, just work with one TCP connection, one HTTP request, and everything else had to wait in line, head of line blocking, that's called, where you can download the index.html file. When the index.html file is back, do the next resource, like an image or something like that. And back in the day, that was okay, but soon people found out, okay, maybe we need something more. And they reworked a little bit the protocol for HTTP 1.1. And you know what's better than having one request? Having two requests. That was actually in the proposal, so you can do 2 parallel requests. Browsers actually went to 6, so you can do 6 parallel requests per domain. I wonder why they never got up to 11. It's beyond me. But still, for each request, for each HTTP request they are doing, you had a new TCP connection. So it was like the server opened up this freeway handshake, this secret gang sign, every time a new resource was requested. And this led to this one advice back when we did performance optimization. The best request is a request not being made. And memorize this. This is coming up lots of time during my presentation right now. The best request is a request not being made. Which meant that we should avoid stuff that triggers requests, like having a source, having a URL in your style sheets, having link href and downloading a style sheet. You should do as few as possible of them back in the HTTP 1.1 days. And to achieve this, we relied on things like concatenation, like combining every JavaScript file into one, combining every CSS file into one, just having one JavaScript file downloaded, having one CSS file downloaded. You've heard of image sprites already this morning with Nico. That's basically just all the images in one file, or all the icons in one file, and you cut out all the little bits and pieces and display them. And of course, inlining stuff, like not making regress at all, pack everything into the HTML and download it. And those were early performance optimizations, and they were necessary because the web was evolving. Right now, this is a screenshot from yesterday from HTTP archive. The average web page is about 2.3 megabytes in total, which is insane. And 2/3 of it are images. And also on average, we have about 40 TCP connections right now that are happening per page. That might not be a big thing if you think about it, but let's say no, actually it is pretty a big thing. But let's say you have an image-heavy website, like the most popular search engine in the world starts with a G. Anybody knows it? Yeah, Giphy. These have lots and lots of images, and if you open this web page on a mobile device where you have added latency, not only getting this TCP request or the TCP connection going on, but also having to connect to a tower, sending your signal into space and back again, and passing Starship Enterprise. That is really something, and let me visualize that for you. That means that you open up 2 connections, and they're pretty good at getting forward, like CSS is a little bit faster than JS, but JS holding up. And then you start with downloading all the images. That was it with your website. You have to wait like indefinitely. And this is why HTTP 2 was made. HTTP 2 was made to serve today's web. And instead of opening a TCP request almost for every HTTP request, like opening a separate TCP connection, They just rely on one connection. And TCP is really good at handling lots of stuff. If you ever downloaded a video or any other file from some place that's really huge, you see that downloading this one file is actually really, really fast, but if you do multiple files, it gets kind of weird. And HTTP2 works in streams, where you have one stream to send requests and one stream to get all the responses. And you can start sending a GET request for one image, and no matter at which time you can go for the second one, and then the server starts answering in small packages that can be assembled on the client. So you have here image 1 and image 2 intertwined and interleaved, and everything comes back to the client and is assembled there. This means that for a website that was done with HTTP 1.1, those gray blocks, those clear areas, are those TCP connections, getting everything going. With HTTP2, you're going to reduce those TCP connections because everything is served by this one TCP connection. So you start a lot faster with downloading your stuff. And actually, since HTTP2 doesn't have a limit on parallel connections, they also start a lot earlier, and that's how this speed up comes to be. There's a nice video from Cloudflare where they're going to combine compare the same web page, one time on HTTP 1.1, one time on HTTP 2, and on the left side it's all of tiny little images getting across the wire, and you can really see how fast it's going to be. So this was the last time I tried it. I'm doing now another one, and this was HTTP 1.1, pretty fast actually. You couldn't even see it, just in the blink of an eye. So that's really, really fast. I tried it with some web pages, for instance, my blog. And on HTTP 1.1, I had about 2.6 seconds load time. That was already a performance optimized blog. But HTTP 2, I had another 800 milliseconds less. And it's even better on mobile because you don't have to connect to space anymore or to the next tower. On mobile, you can really see a speed up. It took about half as long to download this stuff. So it's all about fighting this latency, not making any more connections than you need, because TCP is capable of handling all of that. In turn, this also means that if you have a slow website on HTTP 1.1, you will still have a slow website on HTTP 2. It's just downloading faster, but if you don't follow, or if you don't respect the usual performance guidelines, you still will have a slow HTTP 2 web page. Performance guideline like minifying JS and CSS, optimizing those images, basically everything that Nico said this morning. And the most important thing is do not block rendering. So get the thing that renders your page out there very, very fast, and then just download all the other stuff. And this is top-notch thought leadership here. With that given, HTTP2 is not only here for performance optimization, but it's an engineering opportunity. And this is the part where this whole thing of unbundle all the things comes into place. Let me elaborate. So the best request is a request not being made. You heard that already. This means that you don't have to download. This advice still holds up somehow. Not by just combining everything into one, because this is basically 4 JavaScript files. I wouldn't get any speed up if I would combine them, because this concatenation is basically done in the stream of the TCP connection and just put onto my site. But what I can do now, instead of having one huge file and transferring it over the wire, I can select the files that I want to transfer. So let's say this index.html file doesn't need one of those JavaScript files. I just leave it out. I just transport less weight than I did before. And that's what's meant with the best request is a request not being made. So you don't do this request because you don't need this file. Another example, this is like half of our icons that we have in our product. And a question for the audience, what do you think is faster? Transporting this or transporting those 2 icons? It's of course those 2 icons. So if this or this. So instead of transporting one sprite that has like everything in it and you save it on the client, just get over what you really, really, really need. Engineering step 1, get over what you really, really need. Engineering step 2, and I start with the best request is a request not being made. Again, this can be thought of some differently. What if the client doesn't have to make a request at all? What if you download 2 files, I added some version markers in there, and just set an expiry header of indefinitely, so these files always stay with the client. You can do then things like, okay, just exchanging the second file. So the client gets to this web page the second time, he already has the version 1 from the agent SVG, and he's downloading version 2 from the cloud SVG, he's just downloading the second file. So the best request that wasn't made was downloading agent v1 again. And this is the huge power of HTTP2. So yeah, in some way, unbundle all the things. If you think about this spriting image, that's the way to do it. If you think about not having bytes transferred over that you don't need, that's the way to do it. But there's a little bit more to it. And one thing, or one article that I really, really like, was the one from Khan Academy, where they just took an old jQuery-based web application or web page and didn't do the packaging anymore. And it turned out that the new HTTP2 web page was a lot slower than the original one, for one reason. It was a jQuery application, and everybody who has written jQuery plugins knows that there's a lot of boilerplate code, really a lot. And gzip is really good at repetition. So when they gzipped all those JavaScript files into one when they combined all those JavaScript files into one bundle and gzipped it, the repetition of the boilerplate code actually improved the performance for this bundled JavaScript file. And this is where this rule, like unbundle all the things, fails. In this case, that just didn't work. The gzip performance win was much better than the win they had by activating HTTP2 and just pushing everything over the wire. So what they then did is like refactoring the application throughout a little bit of other JavaScript files. But other than that, really good article to read. And we also made some tests with one application of ours, which I want to elaborate a little more, given the time. Oh, still halfway through with the slides, so hey, let's go in the last 3 minutes or something. Let's go back to these two images. We have the agent SVG, we have the cloud v2 SVG. So I can interchange those images freely. Like I can update this cloud image all over again and all over again. Would you say that if you had to change one image, you have to change the other? They are completely separate from each other. Let's look at this handsome fellow. You can make out that he's an agent or guy or person or whatever. What about now? Something's kind of missing. So this is what we call a dependency. And this is important if you, yeah, your head is a dependency of yours. This is important if you take this rule over to JavaScript. This is some weird JavaScript architecture I was designing. We have versions everywhere, like version 1 of the payment shares, version 1 of validation shares. We have a call to action that validation depends on the overhyped framework, on some Lodash or other utility, and this call to action JavaScript. So every JavaScript bundler works with file names. So what happens if I have to update one version of my call to action JavaScript? I would also have to update the validation JavaScript. So instead of just pushing one JavaScript file out there again, in the next round I have to put both of them, like validation v2 and call to action v2. So let's try to order our JavaScript files in terms of frequency of change. Usually if you're working with some single page application framework or any other library, libraries are pretty rigid. You don't update them on a daily basis. Then you have the utility layer, which means that this is some sort of, maybe left pad or Lodash or whatever. And then you have your modules on top of that. And you can exchange all the stuff on the top level freely without having any fear that you have to change more than one file. But if you change anything below, you have to change everything that's on top of them. So in this one example that we had a rather optimized utility layer. Think of building your own modernizer build, where you just have those tests in it that you really, really like. And a change happened in this layer. Like I had to add some new functionality because one of my modules was using this functionality. This meant that I had to change all the modules as well because this utility layer has changed. And what we did to overcome this, since most of the modules just took a little tiny wee bit of this utility layer, maybe one function or maybe two functions, nothing much. We started tree shaking this. Who has heard of tree shaking in here? Quite a lot. For everybody who hasn't heard of it, this works with ECMAScript 16. It's a mixture between 2016 and 6. With ECMAScript, with the current version of ECMAScript, if you use ECMAScript modules, you can import them like that. And there are tools like Rollup.js or Webpack, the current version of Webpack does that as well, who can just import those bits and pieces that you really need. So if I have a huge utility library and I just want to have this one helper function, what those tools can do is extract those functions. So my module now has those two functions included as well. So instead of having a broad utility layer everybody consumes, we packed those utilities that we needed into the module. And so we had lots of highly flexible modules that we could exchange at will, and the library was still underneath. That was the way we did it there. So that's one way to go. If you request me to answer you what you want to do with your application, remember, the best request is a request not being made. But it's all. I have a few advices that I can give you. The first one is create independent exchangeable components. So every package that you have and that you can deploy without touching everything else, that's a win for HTTP2 because you just can update the version number, everything else is on the client, and you just transfer those little bits and pieces over the wire that you need for the next version. Create small and detached bundles. If you're going to bundle your stuff, try to bundle them in a sensible way so they don't touch anything else. Code duplication and added weight is okay if the file can stay long on the client. That's like me having a belly, so I can go a whole day without food, which I did today. And think about long-lasting applications and frequency of change. So it's good to get a lot of things over when you first download the web page, but people are going to visit your product or your application or your web page, hopefully more than once. So everything they have there already and they can use already is a win. And do we have still 2 more minutes? I made some weird looking into the crystal ball and doing some predictions on how JavaScript frameworks are going to handle this. And the things I came up was like, Ember is going to have a wonderful integrated solution ready, and you can easily migrate to it. It will make for great conference talks, but sadly hardly anybody is going to use it. Angular.js observes the ecosystem for a while and creates the undoubtedly best solution in version 3. To use it, you have to include Angular 1.5, Angular 2, and a bunch of Ember.js modules. And React is going to do nothing. But the community will come up with 3 build tools and 7 different solutions that require at least 7 exclamation marks in their strings. So but might turn out to be false, so don't bet on that. So a lasting remark, and that's also thanks to Jake. Use tools, not rules. And I'm here for about 50 more minutes because now I confused everybody. And at around 4, I have to jump onto a train, go back home, and getting embarrassed for many, many more people at a wedding. So yeah, if you have any questions, ask them quick. Other than that, thank you very much. Thank you, Budapest, for having me. And there's one more thing. I'm immediately going to regret this, but I announced now at JavaScript conference that Linz is going to have in January 2017. And now that I announced it before about 500 people, I actually can't go back anymore. So I'm going to have to do this. But yeah, mark your calendar, January 2017. There's going to be some fun in Linz. All right.